this is the last section that we will cover before our test. Remember, your test is going to be a week from today. This is a big test, so you're going to want to make sure that you do some reviewing between now and then. All right, there are two sides to your handout. Please make sure you are on the correct side. We are going to graph linear inequalities and absolute value inequalities. When we graph linear equations, we like for them to be in slope-intercept form. That's the easiest, fastest way for us to graph. Is this equation currently in slope-intercept form? It's not. So let's put it in slope-intercept form. To start, I'm going to subtract 3x from both sides. When I subtract 3x, I have left 1/2 y is less than negative 3x plus 2. If you remember back to slope-intercept form, we want our x term to come in front of the constant. All right, we're solving for y, so now we need to undo this 1/2. Anybody have an idea of how we can multiply by the reciprocal? And in our case, the reciprocal is 2. So let's multiply both sides of the equation by 2. So we have y. Do we need to flip our symbol here? Do we multiply by a negative number? Nope. Y is less than negative 6x plus 4. Now our inequality is in slope-intercept form. It's easy to graph. What is our y-intercept? 4. So let's put a dot at 4 on our y-axis. The slope is negative 6 or negative 6 over 1. So let's go down 6 and right 1. Down 6 and right 1. I could have went up 6 and left 1 also. That would still be on my graph. Now before you draw your line in, if you remember back to Algebra 1 or Algebra B, will we use a dashed line or a solid line? Dashed. And how do we know that it's dashed?
The line underneath.
Right, it's not underneath. There's not a line underneath. It's not equal to. So take your straight edge and draw in a dashed line.
What?
Now, if we were graphing an equation, we would use a solid line. If there was an equal sign, we would use a solid line, and all of our solutions would be points that fall along that solid line. We don't have an equation, though. We have an inequality. So we've got lots of ordered pairs that are solutions. And our solutions are either going to be points that are above our line or points that are below our line. And we're going to have to test to see which points work.
0, 0.
Very good. 0, 0 is probably the best point to pick just because it's easy to work with 0. So I'm going to take my pencil and I'm going to put it dot at 0, 0. So I'm testing all of the points by putting that one point of 0, 0 in. I'm testing all of the points that fall below or to the left of my graph. I'm going to take 0, 0. It does not matter if you put this ordered pair into the original inequality or if you put it into the one that's in slope-intercept form, because technically it's the same thing. Now I want you to be careful. If you put it into the new one, make sure that you did flip your symbol if you multiplied or divided by a negative number. I'm going to put it into the original. It's a standard form. It's going to be easiest to calculate for me. So I'm going to put 0 in for x and 0 in for y. And I want to know if this is true when I substitute 0 in for both x and y.
It's true.
3 times 0 is 0. Half of 0 is 0. 0 is less than 2. So that says when I put that ordered pair of 0, 0 in, it worked. It was true. So if I was to pick anything on the right side of my graph, would it be true or false?
True.
On the right side, it should be false. Okay, I put 0, 0 in, which was on the left side. So any other point that I pick over here on the left side should also be true. Take your marker, if you would, and shade in the true side. You don't have to color in every single nook and cranny, but just color in the side, make it obvious where your solutions are. Now, just a little word of warning here. If you make a mistake on your homework, please don't just cross out the side that is shaded incorrect and shade the other side. If you make a mistake on your homework or test or quiz, I'm going to ask that you completely redo the graph. Start over. I don't want you to cross it off. Now, if you did it in pencil, you just erase it. Okay, but if you're choosing to use a marker or pen, you do need to start over if you make a mistake.
How you gonna do that
Huh?
How you gonna do it if you didn't
If you did it in what?
marker?
I've got extra graph paper. You can cut it out and tape it to your homework if you want. But I will have extra graph paper for you. Same thing on a test or quiz. If you happen to make a mistake, I'll have extra graph paper. You can just cut it out and tape it over the top. Make it work. So for this first problem, I do want to pick a point that falls over here in the positive side. Let's put the ordered pair of 2, 2 in. If I put the ordered pair of 2, 2 in, it should not work. It should be false. But for this first problem, I am going to go ahead and try it just to see if it is false. So let's put 2 in for x and 2 in for y. 3 times 2 is 6. Half of 2 is 1. 6 plus 1 is 7. Is 7 less than 2?
No.
It's not. That's false. Put a line through to show that it really is false. And that's exactly what we expected to happen. We expected it to be false. Let's look at the one down here below. I'd like to go ahead and put this into slope-intercept form. This looks like a V here. Does yours look like a V instead of a Y? It should have been a Y. It just got cut off. Let's put this into slope-intercept form. I'm going to start by adding x to both sides. So I have 2y is greater than x plus 4. We're solving for y, so the next thing we'll do is divide by 2. So we have y is greater than x over 2 plus 4 divided by 2 is 2. I don't really like that x over 2 because what's our slope? Is it 2 or is it 1/2? It's a half. What number is in front of x? Well, 1. So our slope is 1/2. Most of the time we will see this written as y equals 1/2 x plus 2. Any questions on how I put that into slope-intercept form? Alright, so let's go ahead and take our pencil and graph this inequality. It's in slope-intercept form. What is our y-intercept? It's a 2. Our slope is 1/2, so we're going to rise 1 and run 2. Rise 1 and run 2. Remember, we do need a minimum of 3 points on our line. The more points you pick, the more accurate your graph is going to be. This time we'll use an open or a closed circle to graph this line. Not an open, I said that wrong. We'll use a dash or a solid line. A dashed line. Now remember, if this was an equation, we would be finished. We'd have a solid line. All of our solutions would be points on the line. But we have an inequality, so our solutions are going to be either the area that are above, all the ordered pairs above my line, or all the ordered pairs down here below my line. And we'll need to test a point to decide which or where our solutions are. Do we have to pick 0, 0 every time?
No.
No. And there is going to be times where we can't pick 0, 0. What would be one situation where we couldn't pick 0, 0? If your line was through 0, 0. As long as you pick something not on 0, 0, you should be fine. Or, I said that wrong. Again, if you pick something not on your line, you should be fine. So put 0 in for x and for y. So we have the opposite of 0 plus 2 times 0 is greater than 4. And once again, you could have put this into the original problem or the one that's in slope-intercept form. It doesn't matter. The opposite of 0 is still 0. 2 times 0 is 0. 0. 0. Thank you. 0 is greater than 2 instead of 4. Sorry about that. And that's false. So we tested the ordered pair of 0, 0. When I put it in, it did not work. So I know that all the other points on this side of my graph are not solutions. Where should my solutions be? On the other side. One side's going to be true, one's going to be false. In our case, it's going to be the top of our graph. So take your marker and shade in on the top half. Side, please. This time we are graphing absolute value functions. We've graphed them before. We know to graph them, we're going to use a T-chart. For this one, you could use transformations if you wanted to. I'm going to go ahead and do a T-chart for this function. Let's start with 0, 1, and negative 1. If I put 0 in, the absolute value of 0 is?
0.
And minus 4? 0, negative 4. If we put 1 in, the absolute value of 1 is? 1 and 1 minus 4? Negative 3. If I put negative 1 in, the absolute value of negative 1 is? 1 and 1 minus 4, negative 3, once again. Let's pick a few more points just to make sure. It looks like our V is starting to form, but I want to make sure we have the correct graph. So put 2 in, the absolute value of 2 is 2. 2 minus 4, negative 2. Put negative 2 in, the absolute value of negative 2 is 2, and 2 minus 4. I think at this point we've got a pretty good graph. Will we use a dash or a solid line?
Solid.
Solid line. Transformations here. If we're subtracting 4 outside of our function, what do we predict should happen anyway? It should go down 4. And isn't that what my vertex did?
Yes.
It shifted down 4. If this was an equation or if it was a function, we would be finished. But this is an inequality. So our solutions are going to be a set of points either inside the V or outside of the V. So once again, we're just going to pick a point. I'm going to start with 0, 0. Let's test that to see if it works when I plug it in. So put 0 in for y, 0 in for x. The absolute value of 0 is 0, and 0 minus 4 is negative 4. Is 0 greater than or equal to negative 4?
Yes.
That's true. So I know that all the ordered pairs that fall inside the V, on the side with 0, 0, are going to be solutions. So let's shade in on the inside of our V. value function, and I know that because there are absolute value bars. What do you predict the plus 3 is going to do to our parent function?
Is it up 3?
Going to go up 3. What about multiplying by 2?
It's going to stretch it.
It is. It's going to stretch it vertically. It's going to do this to my graph. So it's going to make it narrower. It should be more narrow than the parent function, and it should be shifted up 3. I want to go ahead and do a t-chart. We're not going to use transformations, although you could. Let's start with 0, 1, and negative 1. The absolute value of 0 is 0. 0 times 2 is 0. Plus 3. Put 1 in. The absolute value of 1 is 1 times 2 plus 3.
Plus.
Put negative 1 in. The absolute value of negative 1 is 1. 1 times 2 is plus 3 is? Let's put 2 and let's put negative 2 in. I think we have a pretty good idea of what our graph is doing, but let's test some more points. The absolute value of 2 is times 2 plus 3. So it's negative 2 in. The absolute value of negative 2 is 2. 2 times 2 is, and 4 plus 3 is 7. Should we use a dashed or a solid line for this graph? Solid. And how do we know that it's solid? What it tells us? Right, it's equal to. If it had just been less than, we would use a dashed line. Or if it had been a function or an equation, we would of course use a solid line. Okay, once again, we have an inequality. We have to test a point to see which side we're going to shade. I would test 0, 0. So let's put 0, 0 in for x and y. See if it's true. The absolute value of 0, 0 times 2, 0 plus 3. Is that true? Is 0 less than or equal to 3? It is. So this time we're going to shade the side outside of our V, below our V. Right as far as numbers for your answer. Your graph is your answer. I'm looking to see, is your graph in the correct placement? Does it have a solid line? Is it shaded in the correct position?
Oh, yeah.
There's lots of different things that we'll check when we grade these assignments, so make sure that you're paying close attention to detail. Once again, if you make a mistake, or using pen or marker to shade, you're going to need to completely start over. I don't want you just to X out one side and shade the other side. You need to start over. I want to see a visual of where it's done correctly. Okay, I do have some problems for you guys to practice. They're going to be out of your book. I have given you a graph paper. There's 5 of them. Got some graph paper for you to do your assignment on. Would you copy down the problem, please? Copy them down.
Oh, there's no more.